Welcome to Webinar Wednesday. Today is Wednesday, December 13th. My name is Steve Tucci with Shadler Yesco, and today's topic is going to be fiber basics, fiber optic end face inspection and cleaning. A little bit about myself real quick. I've been in the datacom industry for 27 years. Spent the first 15 years of my career in the field, and I've been with Shadler for the last 13 years. I am a BICSI certified technician as well as a BICSI certified trainer. Shadler Yesco has a BICSI authorized training facility at our York, Pennsylvania branch. And we host the BICSI ICT program classes at that facility, where I am the facilitator of those classes. I also have several other certifications related to the datacom industry, Hubble premise wiring, mission critical, STI fire stop, fit level 1 certified, as well as multiple certifications with APC regarding data centers and UPSs. So that's a quick little bit about my background. So why do we clean and inspect fiber end faces? Well, everybody knows the old saying that cleanliness is next to godliness. And when we talk about fiber, that is absolutely the case. 98% of contractors and 80% of network owners have reported fiber failures due to dirty end faces. And to compound that, 82% of contractors and 34% of network operators and owners report fiber failures due to shattered end faces. Well, how do we prevent that? We prevent it through inspection. And when we inspect, we're not inspecting just for dirt and debris. We're also inspecting for flaws, defects, shattered end faces, that kind of thing. Household dust can be anywhere from a half of a micron to 100 microns in size. So that's kind of shocking, because if we talk about single mode fiber, the core of single mode fiber is 9 microns in diameter. So one speck of dust on an end face of a single mode fiber optic connector could potentially block the entire core of that fiber. Not only is dust an issue, but static is an issue. When static builds up on our fiber end faces, it tends to attract dust and debris to those end faces, which only makes our contamination issue even worse. And then as we're handling our connectors and our patch cords and that kind of thing, oils from our fingers and our hands can migrate onto the connectors, which again causes issues with loss. The other big reason that we want to inspect and clean is it will help to prevent cross-contamination of our active electronics. So that's hugely important, because the electronics are very expensive. One 10 gigabit SFP module could run you upwards of $1,000 to replace. Whereas taking 5 minutes to inspect and clean a fiber connector, does not cost much money at all. So it also helps to ensure reliable connections with minimal amounts of loss. And then the only way to identify dirty or shattered end faces is through inspection. We're talking about a connector who, like I said previously, single mode fiber, the core is 9 microns in diameter. Multi-mode fiber, depending on the type of multi-mode fiber we're working with, the core could be anywhere from 50 microns to 62.5 microns. It's virtually impossible to see that with the naked eye. So we need to use some sort of inspection scope to be able to see those cores. So there is a workflow to cleaning and inspecting our fiber end face. So we want to start out by inspecting. So we're going to connect our fiber optic connector to some sort of inspection scope. We're going to take a look at it. Is that connector end face shattered? If it is shattered, we're going to repair that end face by cutting that connector off and re-terminating it. Once we've completed that, then we're going to basically go back to the beginning. Then we're going to inspect again. So if the end face is not shattered, then we're going to take a look at it and determine if that end face is clean. If the end face is clean, we're good to connect that connector to whatever device we're connecting it to. If that end face is not clean, we need to clean the end face and then start back at the beginning and inspect again. So it's kind of a closed loop. So, and I threw this little quote up here. I came across this the other day and I thought it was kind of interesting. A quote from Benjamin Disraeli. He says, cleanliness and order are not matters of instinct. They are matters of education. And like most great things, you must cultivate a taste for them. And that applies to working with fiber optics and inspecting and cleaning fiber optics. It is a learned skill, and it is something that you just have got to make yourself get into the habit of doing. So moving on, how do we inspect and clean fiber end faces? So we're going to use either an analog or a digital inspection scope with magnification. We're going to follow that end face inspection and cleaning workflow that I just showed you. We're going to perform the cleaning as needed. And in order to perform that cleaning, we're going to use the appropriate cleaning tools for the application. So we're not going to use the same type of cleaners for all applications. If we've already got connectors that are installed into a patch panel, we're not going to disconnect those connectors from the patch panel to inspect and clean them. So you just need to make sure you have the right tool for the application. We're going to use the preferred method to clean the connectors. And the preferred method is what's known as a wet to dry cleaning method. So in a wet to dry method, we take a lint-free wipe. We're going to put some fiber optic cleaning solution on that lint-free wipe. We're going to start at the wet area of the wipe. We're going to drag our connector end face across the wet area into the dry area in one motion. That's our cleaning motion. It's known as a wet to dry cleaning. Like I mentioned, we're going to use a fiber optic cleaning solution instead of using isopropyl alcohol. Used to be, when I started in the industry 27 years ago, you were doing fiber optics, you ran to CVS, Rite Aid, Walgreens, wherever, picked up a bottle of isopropyl alcohol off the shelf. That's not good enough anymore. Isopropyl alcohol, number one, is highly flammable. Number two, isopropyl alcohol actually contains water. And whether you may realize it or not, isopropyl alcohol actually attracts water. So it will pull water out of the atmosphere, and that water can collect on your fiber end faces. When isopropyl alcohol dries, it actually leaves a residue. So that residue can cause issues on your fiber end faces. And then, like I also said, you want to use a lint-free wipe for obvious reasons. Just kind of, if you wear glasses, kind of the same reason there. We don't want to have debris left behind while we're cleaning. Kind of defeats the purpose of cleaning. And I have a couple images here of some of the various tools and cleaners that you would use. So this scope here that I'm pointing at is an analog scope. To the right of that is a digital scope. Then we've got several different cleaning products here. We've got the lint-free wipes. We've got click cleaners, which would be used for a dry cleaning if you had to. Here in this bottle, we have the fiber optic cleaning solution. And then these guys here, depending on the manufacturer, some manufacturers refer to them as clean sticks, just another method of doing a dry cleaning to remove dust and debris off of the fiber end face. So the microscopes, they are the important part of the inspection process. Analog scopes are available in 100, 200, and 400 times magnification. Analog scopes are a 100% manual process. You do not have the ability to save images when you use a analog inspection scope. The analog scopes rely on the skills, abilities, and judgment of the technician performing the inspection. And you cannot produce any kind of documentation when you use an analog scope. As opposed to a digital scope will have low and high magnification. Digital scopes have an automated end face evaluation process. And that automated process evaluates the end face against the current IEC 61300-3-35 standard. And we're not going to get down in the weeds as to what that standard says, but real high level, that standard establishes 4 zones in that end face. And there is an allowable amount of debris that is allowed to be in each zone. And the scope or the software that the scope is using will generate an automated pass or fail. And I'll show you some images of that here momentarily. The scopes, since the digital scopes can save images and they can produce reports. Like I mentioned, they will provide an overlay of the 4 evaluation zones. And you can see that in the image down below here. You can see the green ring, and then you can see the violet ring, and then there's a black ring. And then it's very hard to see, but there is a yellow ring in there as well. They're your 4 zones. Inspection scopes can be, the digital scopes can be either standalone, or they could be a component of another piece of test equipment. So Stabler-Jesko owns an OTDR that I use for the BIXI training classes. That OTDR has a digital inspection scope with it that can be used with that OTDR only. Many inspection scopes that are on the market are USB. They can plug directly into a laptop. They can plug into other types of test equipment. So it just is a matter of what you're trying to accomplish as far as which scope is the best fit. We do stock digital scopes, and if anybody is interested in information on those scopes, by all means, please feel free to send us an email or give us a call, and we can absolutely get you information on that. So inspection and cleaning results. So I did some testing at my desk the other day just so I had some images to show. And I want to share this with you. So this was taken using a digital inspection scope. This was a brand new patch cord that I took out of the bag. So you would assume brand new cord would be clean. I could just unpackage it, take the dust caps off, plug it in, and I should be good to go. Well, as you can see, it failed the automated evaluation. And we can see that in zone B was where our failure was. And if I scroll down, it gives me the analysis details. It says that I had more than 5 defects that were greater than 2 microns in diameter within zone B. So zone B if you look at the high magnification image here on the right, zone A is this blue circle. That is my core of the fiber. Zone B is what's known as the cladding area. That is the area between the blue circle and the green circle. That's zone B. Zone C is my area between the green circle and the purple circle. That's what's known as the adhesive zone. And then zone D is the area between the purple circle and the black circle. That is known as the ferrule zone. So just a real quick example of why inspection is important. Like I said, this was a brand new cord and it failed. So I'm going to pull up another image of a patch cord that is contaminated with oils from my finger. So this is a quick image of, like I said, a connector that is contaminated with oils from my finger. Again, this was a brand new cord that I pulled out of a bag, and I just touched the end face to my finger. And you can see how much contamination transferred to that end face. So if we look at the analysis detail, shows zone A had more than 0 defects. Zone B had defects greater than 5 microns and more than 5 defects greater than 2 microns in diameter. And then zone D had defects greater than 10 microns in diameter. So again, just stressing the importance of end face testing and inspection. Anybody have any questions that were submitted through the chat?
It doesn't look like I see any coming through, Steve.
Like I said, if anybody has any questions, feel free to call, email. If anybody would like more information on that digital scope, by all means, feel free to reach out and we will get you the information that you need. And I think that's about our 20 minutes. So we will wrap it up and call it a day. I appreciate everybody's time and have a good afternoon.